the Sustainability Management Master's Program, you're answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
The Stevens Institute of Technology is proud to present the Hugo New Corporation Sustainability Seminar Series, brought to you by Brown and Codwell, Geocetic Consultants, H2M Architect and Engineers, BEM Systems, and Catalyst Group.
Professor, thank you so much. I'd like to thank Samir as well and Stevens Institute to be a part of this sustainable seminar. My name is Rory Stout, and as you just heard, I've been a technical rep for some time now in the energy efficient, sustainable industry of liquid applied roofing and waterproofing systems. But I was asked to kind of, before we get into the presentation, just explain a little bit about my background. My degree is in history, and how I came to be a technical rep in sustainability and energy efficiency. And that journey started with Hurricane Katrina down in New Orleans. I went to school at Montclair State University, a state college. I went to a community school and transferred specifically to keep my costs down. Towards the end of my senior year, the idea came to me to go down to New Orleans and help volunteer, and went down and ended up getting a job at the Brad Pitt Make It Right site, which at the time was the largest leadership in energy and environmental design, the largest LEED Platinum building site in North America. And I was a landscaper. I was brushing the streets on the construction site to planting flowers and plants for the different houses. And my eyes opened up to the different technologies, from solar panels to green roofs to houses on stilts, because of the area of the lower 9th Ward and the levees. So all of this opened up my eyes. I came back up to the Northeast, looked into green roofing originally, vegetative roof garden systems that are also sustainable and very key and important component to sustainable roofing, and ended up getting a job in Philadelphia. The company was training for Green Roofs for Healthy Cities, which is a whole nother organization. If anybody goes that path as a specifier or an engineer and gets involved with Green Roofs for Healthy Cities are based out of Toronto, and that is the governing body in North America for vegetative roof garden systems. And was offered a class. And in that class, real quickly, I had everyone from college graduates to people who had just gotten out of prison to people who were unemployed. And it was a wonderful mosaic of people in that classroom. And I was taught from a nonprofit. There was a grant that was given, a local bank funded the program and trained us. And at the end of that program, I was offered a position with a startup green roofing company that had been around for about 6 years. And we started installing green roofs and cool roofs throughout the city of Philadelphia. And that's kind of how my career started. And we will jump here to the presentation, but this is an ever-growing market. and we are just starting to, cut our teeth. We're just scratching the surface of the needs and understanding the industry that's evolving before our eyes. I got in this in 2010, so I'm going now on 11 years in the industry, and it's still so brand new. So for all my young students and young people and people in general, this world can be very challenging and difficult at times. And this is a market and an industry that you can get into uh, and not have to have a PhD or such a specific degree to get into this field, as kind of my story a little bit goes. And, any questions later on after the presentation, don't feel free to ask, and I'm here to help. So welcome all students and everyone who's tuned in the presentation here by Acrolabs. Title here is Liquid Applied Membranes, an introduction to the use of high performance acrylic coatings in creating sustainable and energy efficient systems. Those two terms are used very freely in society now, kind of like organic and elastomeric, some of these terms that you hear in the green building industry. And what is sustainable and what is energy efficient? Sustainability, the ability to sustain a product, sustain something, and prolong the life of it without having to dismantle that or throw it away. And energy efficient, the ability to reduce our consumption on carbon footprint and to utilize the efficiency of the building to either reflect the UV and solar rays to reduce our energy consumption in the building, cooling, the ambient air temperature, all these things that we'll get into that you hear a lot of these terms and how they're applied specifically to the liquid applied roofing industry with what we do. This picture here is a commercial industrial building. And this is kind of what we do. Our systems are applied over the building envelope. The building envelope is the exterior of a building. You might have learned that term in class. That goes from the roof to the walls down and is the envelope of a building, building envelope. So let's go to the first slide here. And this slide here is original fluid applied roofing. So the history of fluid applied roofing, this is not necessarily a rubber roof or an asphalt roof or a metal roof. We're actually using high performance liquids. And in our case with Acrolabs, we're using a high performance acrylic waterborne coating. And I know that's kind of a mouthful, but just remember acrylic waterborne. And it's environmentally friendly, very low VOC, volatile organic compounds, as well as very low odor. So everyone from who's using the product to people in the community where the project is going on don't have to worry about the odor or the product harming them. And that's very important, as well as the performance of the product that we're asking for it to do on the building envelope, which is exposed 24/7 to rain, snow, sleet, wind, hail, 7 days a week, 12 months out of the year, 24/7. So we then cut back 30, 40, 50, 60 years or so. And in this first slide to the left, everybody thinks Shawshank Redemption. To any of my students who've seen that movie, there's a clip in that movie where they go up on top of the roof and they're using a hot mop. And that's what you see here. It's a hot mop and that's a kettle. And they're basically putting hot asphalt or tar down onto that roof. And you can see from that image the amount of smoke and heat that's radiating off that roof. That smoke and fumes are not good and not healthy to the individual who's applying that. But that's actually the history of liquid applied roofing, believe it or not, is right there. And that's a hot applied system. We're a cold applied system because you don't need heat in a kettle to boil up the asphalt to apply to a roof. This system has since been outlawed but they were wonderful roofs. They're still performing to this day. Excuse me. Some are still 30, 40 years old, still performing. But just to kind of give you where we've come from, showing you the origins of the fluid applied or liquid applied roofing. We then graduated to the aluminized silver coatings, which are also asphaltic in property, oil-based, should we say. And the aluminized silver coatings were utilized to put oils back into the asphalt. And that aluminized silver coating is asphaltic in property. So as the sun shines down and heats up that surface, it dries out the oils, and that aluminized silver coating dries out and it cracks. So we now have graduated to the composite liquid applied membrane systems. And for Acrolabs, this is our liquid applied membrane system. It's UV resistant. So it's not going to break down from UV rays shining from the sun. There's nothing to leach out. There's nothing to dry. The system is UV resistant. And this membrane system can be utilized over the entire building envelope. So from traditional building, we're using materials like metal. We're using materials like rubber, asphalt, wood, and all these things, every pun intended, right, don't grow on trees. It's not infinite per se. We don't have an infinite amount of these building materials. And this is where Acrolabs and the liquid applied roofing systems come into play for the future. This is a renewable or sustainable system. What you see in this picture is the first coat down on the bottom. If everybody can see that gray section, is the first coat that goes down onto a surface or a substrate or a membrane. All those terms are kind of connected and can be the same thing. So whether this system is going over new construction, going over plywood or insulation board, whether it's going over top of an existing metal roof or flat roof, whether it's being applied into a gutter that's metal, we are becoming the roofing system that is renewable. So that first coat that you see goes down onto the surface. The white line that you see is the polyester fabric. We embed polyester fabric into this coating, and then we saturate over top. That creates the membrane. A membrane is your waterproofing element to any waterproofing system. Fiber and glass, fiberglass, embedding fiber into that liquid glass. So when you embed fabric in between liquids and it cures or hardens around that, that creates a membrane. It's not a coating only option. It's now a membrane system. And that gives it its strength and durability to perform long term. The two other lines, you see kind of a light brown to designate that, and then another white finish, are the two top coats that then go over that membrane to create the composite system. So when you combine all those coats and you gain mill thickness, a mill is 1/1000th of an inch in how you rate the thickness of building materials. When you combine all of that and let it cure, you now have a waterproofing membrane system. And the beauty of this system is that we can apply this almost anywhere in the building envelope world over traditional building materials that you would eventually tear down and throw away. The beauty of this system is that every 10, 15, or 20 years, depending on the amount of coats or finish coats, the two here, but we also do 3 and 4 for a 15 and 20-year system. This is our 10-year system. The beauty is at that 10, 15, or 20-year mark, all you have to do is apply one more finish coat and you get another 10 years out of it. So that's where it's renewable and sustainable. And if you maintain this every 10, 15 years, or if you have a 20-year system every 20 years, and you recoat it, you'll never have to tear this system off again. And that's now, as you understand what we're looking at and why it's important, is because liquid applied roofing systems that are renewable are a huge component in the building industry. I think I read somewhere 50% of developed land or surface area, whether a town or a suburb or a city, roughly 50% is covered by roofs and roadways. And those roofs and roadways are usually darker in pigment, and they soak up a lot of heat. And we'll get to that later, which causes the island heat effect and different terms like that you might have learned in class. Components of the system, you typically have a base, which you're embedding the fabric into, and your finish coats. You're also utilizing polyester fabric, which is in the lower left, and the tools to apply this are very simple. We're talking about brushes, rollers, or sprayers. So there's no tearing off. There's no machines that are cutting into anything. This is a very user-friendly system that's asked to perform in very challenging environments. So whether you're a specifier, whether you are going to go into a tradesman or a tradeswoman, what have you, or whatever you field you go into sustainability, these are the kind of products that are going to be asked and become the norm, and also probably become regulation, is having products that are renewable and sustainable, as well as being energy efficient, the ability to conserve energy. We kind of highlight a lot of roofs here, but we'll get into later on in the presentation where we're utilized on walls, and I'll also give you some other applications that we're doing as well at the very end of the presentation. But this gives you an idea, and roofing is so, it's out of the purview of a lot of people's minds, right? You see people painting because someone has come into your house and painted the walls, or maybe you've helped mom and dad paint. Carpentry, you see carpentry, but roofing is something that's out of the, right, out of sight, out of mind. It's that thing that's up on top of the building that you're in studying. It's the thing that's over your house that protects you from the rain. So even looking at these images sometimes are kind of new to people and never really maybe have even seen a commercial flat roof. Maybe in a movie like Shawshank Redemption or something, you see a snippet. If it goes over the top of a city, you'll see the flat roofs. But what you see here on the slide to the top left is an asphalt roof, and we're putting our liquid applied membrane system over top of that. It's actually a granulated asphalt roof, and those granules are gray. And the granules are there to protect the asphalt underneath it from the sun. Kind of the same concept as where we're at now with the liquid applied systems being energy efficient. Problem is the rain and the wind blow those granules off, the asphalt becomes exposed, the UV rays break it down, and in 20 years, they're tearing it off and throwing it into a landfill. Here's a fun fact. 15% of all landfills in the world are made up from roofing materials. Just think about that for a little bit. So here we have in this picture, someone rolling out the base coat, the polyester fabric rolling into that wet coat, and someone saturating over top. Those are those first two coats in fabric that I explained earlier. That's the membrane. Eventually, once that dries and cures, they'll come back over top and put at a minimum of 2 finish coats to create a 45 mil membrane. 3 top coats would be 50 mils, 4 top coats would be 60. And the thickness of the system determines the length of the performance and the warranty before you have to recoat it. The roof on the bottom is actually a rubber roof that was ballasted. It had stones sitting on it. Believe it or not, they used to use stones on flat roofs through the 70s and 80s, even up into the early 90s, with the same concept, protecting the roof from the sun. So these have always been challenges in human history, right? We've kind of gotten away from living and working with Mother Nature, and we're slowly, the pendulum is swinging back, whether it's our food, our diet, or the way we think in the building world. We're swinging back and realizing that we have a climate crisis in front of us, and we need to use products that are energy efficient and renewable. So instead of throwing that rubber roof away, we vacuumed, believe it or not, they vacuum the stones off. There's machines that actually take the stones off the roof. They cleaned the roof. If you can notice, there's metal plates on the rubber. They mechanically fastened it down because the stones would hold that roof in place so the wind doesn't blow it away. We fasten it down, and then we put our system right over top. Again, negating the tear off and putting that roof into a landfill. The roof to the right is a metal roof. We're utilizing the fabric where needed on metal. When you put a metal roof or you install a metal roof, you have seams. Just like on a rubber roof or any other roof, you have seams where the building material overlaps. And that overlapping is so critical to create something that's watertight. If you don't have an overlap, you have an opening into the building and water can get in there. So on a metal roof, we utilize the fabric just where needed. So a ridge cap, which is at the very top, is the very top of the roof. That's called a ridge cap. Sometimes it allows the roof to breathe and vent. And then we use it at the vertical and horizontal seams. When I say we use it, we utilize a 4-inch or a 6-inch width size fabric to just go over where the metal crosses or overlaps, and that's a seam. The seam is susceptible to expansion and contraction, right? So when a building or a roof heats up, you have movement. When it cools down, you have movement, expanding and contracting. And buildings are doing that 24/7 all day long, believe it or not. Your roof is expanding and contracting, and that's where people get leaks. So these materials are elastomeric. So not only are they sustainable and energy efficient, they're also elastomeric. You might have heard that term. What does elastomeric mean? The ability to stretch and come back to its original form, right? So if a building expands and contracts, you also want a material that's going to be able to expand and contract and not snap and break. And that's where the liquid applied systems come into play as well, that they're a lot more flexible than a traditional roof. And that's typically where you get leaks, is with the expansion and contraction of a traditional building materials. Just another visual here of the metal. We have a pretty up close picture here of showing how the fabric completely conforms to the seam. All right, so they have applied in the top right, they've applied a base coat and they're embedding the fabric into that base coat, making it completely conform to the seam. And then they're going to coat over top. And the bottom left, you can see that the gentlemen there are spraying. So you can either brush, right? The tools, you can either brush, roll, or spray this application. And, you know, these big commercial metal roofs, these metal roofs soak up and they're very hot, right? That's something else, that these buildings radiate so much heat, and that heat gets spread out or radiate into the atmosphere. So not only do the people inside of those buildings have to feel that heat, right? But people walking in the street, people that live in that neighborhood are going to be affected by that heat. And these are all things that play into sustainability and green building, right? That's a generic term, but these are the things that now people are taking into consideration because of the island heat effect, where a city or a suburb or an urban area has such, from roofs to the building envelope, building materials that are soaking up that heat. They're not energy efficient. They're not reflecting the UV and the heat off of their buildings. So they're soaking up the heat. The roadways, right? Typically your paved roads are darker pigments. So they're soaking up all that heat. So if you have a town maybe 10 miles outside of a city, your temperature on a summer day might be 80 degrees, but you go into the city and it's 100 degrees. That temperature difference creates the island heat effect. And that's a huge component of pollution, storms, a lot of things that contribute to climate crisis and what we call global warming. At 50% of the land used in these areas, like I said before, are roofs and roadways. We can make a huge impact by creating surfaces that are solar reflective, right? Not only are we helping the building owner by making it watertight, sustainable and renewable, but also energy efficient. Kind of see the big picture here. This is a picture of a church in Massachusetts, and this is a hyperbolic paraboloid roof. That's a mouthful. That word is right down on the bottom left, and we will not quiz you on that. This roof is actually cementitious, and just showing the unique angular shape of this roof. An architect had specified it, or an engineer had specified it. They built it, and aesthetically, it's seamless. This was a seamless structure, right? So pleasing to the eye. When I say seamless, you didn't see a metal roof seam or a flat roof with seams and overlaps. It was built to be visually appealing. So we show this slide because if you notice on the top pictures, they used, after the roof had serviced its life, right? All building materials have a shelf life or a service life. And if they're not renewable, eventually you have to replace that. So it cracked over time and started to leak because I think, had been up there for about 25 years. And this was in Massachusetts. So you can only imagine snow, ice, hail. Definitely gets colder than us here in the mid-Atlantic in the winter in New England. So it was a challenging environment. And you see the paint, they didn't know what to do. They didn't want to put a rubber roof and change the look and the feel of the roof. So they were painting it because they didn't know what to do. Well, paint isn't a waterproofing material. Even though we are liquid applied, paint and an exterior coating system, which we are, similar components, but different performance. So we actually had to sandblast the roof to get a lot of the coating, or a lot of the paint, should I say, that was utilized and wasn't working. So once they heard about us, we came in, and you can see in the top picture how the membrane is being applied right over top of that roof surface and offering a waterproofing membrane system that can also give them the color, the solar reflective white, as well as create the aesthetics that they were looking for without the seams. So just kind of showing the different roofing systems that are out there and the challenges that come with those roofing systems. Just want to make sure my time is going right here. Oh, I'm kind of down here. Give me a second. My charger here. There we go. Give me 1 second, everybody. Just have my charger. There we go. Okay. Difficult connection details. Believe it or not, you see this in the building world where you'll have a flat roof that has been put down where there was a leak on a metal roof. Again, traditional building materials. People are trying to solve and fix problems in the building world with traditional building materials. And those traditional building materials aren't always, from a waterproofing standpoint, don't always work. So you see a metal roof, and then on the lower left, you have a rubber roof. And you can see that there's different things going on. And what those things are, where that connection is they used foam. They've used muck, or what we call asphalt emulsion, to try to make that watertight. Because the metal in the EPDM, or the rubber, is expanding and contracting at different building or different temperature and moving rates, because they're heating up and they're cooling down. And it's a very difficult connection detail to bridge, because you have metal and then you have rubber. With the liquid applied membrane system, this is where we shine. You can see we did a partially reinforced system over the metal that seamlessly transitioned to the flat roof to create one composite membrane. Again, excuse me, I just want to make sure I'm charging up here right. Okay. And this is where you had metal and you had rubber heating up that was radiating all that heat into the atmosphere. Not only do we make this watertight and one monolithic membrane that's renewable and sustainable, but also energy efficient. Problem solved. And these are going to be problems and issues that you as specifiers are going to have to deal with. whether in new construction, developing a system that's going to make sense and be watertight, because that's one of the biggest components of a building is you want to protect the weather from coming in, or if you're doing a restoration project, being called to come in and fix a problem of an existing building. So liquid applied systems not only perform and work in the new construction world, but also the restoration world. This is a picture of Jersey City. So right where Stevens Institute is. Sorry, guys. I just want to make sure my charger for my computer is set up right. I'm down to 1% here. This is called bridging dissimilar materials. And this is what you see on a lot of these older roofs, okay? You see asphalt, you see masonry, you see metal, you see a variety of different building materials. And the picture to the bottom is an Acrolabs roofing system adhering to all these different building materials. There could be 3 or 4 roofs on that roof. Under building code, if there's 2 or more roofs, you have to remove that because of the weight, okay? The fact of the matter is, because we're lightweight and under building code, these systems can go over 2 or more roofs. So it prevents a tear off, helps the building owner save and conserve money because a tear off is very disruptive and expensive. And we're preventing that roof from being ripped off and thrown into a landfill. So again, you have a lot of different things going on a roof. You have vent pipes, you have parapet walls, you have different building materials. And this is one product that can adhere to all those surfaces and make it watertight. Excellent adhesion. This is a lookout up in Maine, and just showing how the membrane system is going right to plywood. It's adhering to the stone walls, the stainless steel grates, and the galvalume posts. Again, different building materials. This system can go right over top of those existing building materials. And this is also a lookout. So not only can these liquid applied membrane systems be watertight, they can also make it able to have foot traffic walk over top of it. So excellent adhesion. And that's critical. If you're not getting good adhesion to an existing surface and you pop off or lose adhesion, well, then that can be very damaging, not only to the project, but to the building. The roof can blow off, it could fail. So you want a product that's going to not only adhere properly, but also perform. And deck surfaces also a roofing system. So not only is this surface acting as a roof, it's also a deck. So a roof deck system. So people can actually walk on these systems as well. Avoiding costly tear-offs. This is actually near our plant. Our plant is in Reading, Pennsylvania, so American made, American owned. This image right here, they're showing that they were trying to scrape off an existing roof. So we talk about tear-offs, that's what a tear-off looks like. It was an asphalt roof and they were trying to scrape this off of a concrete structural deck. So in the construction of roofing, you have a deck, right? Structural deck, typically insulation, and then your roofing system over top that's going to provide the waterproof protection. So they were trying to scrape, right, the existing roof off of that concrete. Where that roof is going to end up is the local landfill, and it will sit there for a very, 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 very long time. No demolition costs, no contribution to landfills, no exposure to the building occupants. As they rip that off, it's very noisy. It opens up basically the building to the elements until they can put a new roof over top, and no damage to existing insulation. So once we came out onto the job, we told them to stop tearing off, and we went right over top of that existing roof, and that slide to the top there in the picture is before and then the after of the Acrolabs system being applied right over top. Again, renewable, sustainable, energy efficient, watertight. All right. So tear-offs, the building norm for a lot of construction projects is something that we're looking to avoid. Because every tear-off contributes to going into a landfill, and it's costly. So we're looking to not only be efficient from energy, we're also looking to be efficient monetarily. And that's a key for all you young students out there, is living your life efficiently. Phased applications. This is actually SUNY, Stony Brook, right? State University of New York out in California, right? UCLA, University of California. Well, in New York, that's SUNY, State University of New York, and you have campuses all over New York. But one of the big ones out in Long Island is Stony Brook, on the eastern end of Long Island. And this is another benefit of the liquid applied systems, phased applications. So what you're looking at here is, again, another example of a real world, real life situation, right? You have an existing roof and they've done a little bit of everything on this roof. So what does that tell you? They've had leaks. They've had a budget. Everybody is on a budget. Excuse me. And I should have mentioned that on the previous slide, is that, you know, these kind of projects are expensive. Especially when you talk about big square footage. So not only are you factoring in the lead credit points and things like that from a specifier, you also have to know your customer. You have to know your client. What is their budget? Everybody is on a budget, right? Even the government, believe it or not, is on a budget, even though they might not act like it. So you have a lot of different factors and components that factor into a construction project getting completed or even started, right? So phased application, we're looking at this roof. You see metal, you see some darker asphalt emulsion that they use for patching. There was a leak there and they tried to repair it. Then you have the existing asphalt membrane. It looks also like those gray granules on this surface too. So this also could be granulated. The white is the liquid applied membrane. And again, typically on a flat roof for energy efficiency, we're going with a white finish. That white finish is solar reflective. To be a cool roof, well, we'll get to that. That's the next slide. We'll get to that. And I'll explain what a cool roof is, because that's another one of these terms that you hear: elastomeric, cool roof. So for phased application, the beauty of the system, of a liquid applied system, is that you don't have to do the whole project. You can phase this in. So I think this project, this was a little less than 100,000 square foot roof, big roof. They had a $30,000 budget. So with a traditional roofing system, if you don't have the budget, you don't do the project, right? You either have the money or you don't. You can't phase in a traditional roof. You either do it or you don't. With liquid applied systems, you can phase it in because we don't have things like counter flashing or a termination bar. Counter flashing and a termination bar protect the seams or the edge of a traditional roofing system. Because we're seamless, we don't have to worry about those things. So we can apply these systems anywhere on a roof or building envelope, and in that exact spot, make it watertight. So what you see here is the first year within their $30,000 budget for, I think it was a 90,000 square foot roof. We broke this up into 3 years.